Okay, this is 11.6, surface area and volume of spheres. Okay. The objective, students be able to find the surface area and volume of a sphere. We are going to break these notes up into 3 parts, surface area, then volume, and then solving the find radius. Now, sphere, the set of all points in space equidistant from a given point, and that is the center of that given point. Okay, and then we have a radius coming out from that point, and that's the same all the way around. The center, the given point in the middle of the sphere, so keep in mind that's the center. The radius we just did with red is a segment that has one endpoint at the center and the other endpoint on the sphere itself. The diameter we'll do in blue here, if that'll show up. Okay, and a diameter goes through the sphere from one side to the other, but a diameter's got to contain the center. Okay, so a segment passing through the center with endpoints on the sphere. Now, when a plane and a sphere intersect in more than one point, the intersection is a circle. So when I intersect right here, if I had a plane that just like my sphere was sitting on it like a ball on the ground, it would be a point. But as the plane penetrates the sphere, okay, the intersection is a circle. Okay, if the center of the circle is also the center of the sphere, so if the center of the circle is also the center of the sphere, it's the great circle or the equator. Okay, if you think about the equator, because the equator is the center, the great circle of Earth, and that would be this one where it contains the center, that cross section. The circumference of the great circle is the circumference of the sphere itself. That's what we're talking about here. And a great circle divides a sphere into 2 hemispheres. So if this were Earth, this would be the northern hemisphere, and then this would be the southern hemisphere. Now, a baseball can be modeled, let's do this, can model the sphere. To approximate its surface area, you can take apart its covering. And these are the coverings from our baseball, okay? There isn't any overlap or anything. Each of the 2 pieces suggests a pair of circles with radius r, which is approximately the radius of the ball. Now, the area of the 4 circles, 4 pi r squared, suggests the surface area of the ball. What they're saying is that this area and this area, along with this area and this area, are what approximates the size of our circle. You know, our radius of those is generally the radius of our sphere that covers the baseball. So the surface area of a sphere is 4 pi r squared. So 4 great circles will cover a sphere. Now, check it out. That's what we just said. Crazy. The surface area of a sphere is 4 times the product of pi and the square of the radius. So 4 pi r squared is our surface area. So we're just going to use this formula. Finding the surface area of a sphere. So every time you use a formula, surface area of a sphere is 4 pi r squared. I need one dimension. I need r. And r happens to be 5. I'm provided a diameter. Half of 10 is 5. So this is 4 pi 5 squared, which is going to be 25 times 4, which is 100 pi meters squared. And that's in terms of pi. Now, again, and I've been harping on this all year, okay, that once you have no picture, the problem's harder. You got to know more. So they tell me the diameter is 14. That means my radius is 7. And then my surface area now is still 4 pi r squared. So 4 pi 7 squared. And I'm going to do 49 times 4. Now, if I need a calculator, I'll go 49 times 4. That's me 196 pi. So this is 196 pi inches cubed. Excuse me, squared, not cubed. I was thinking about my next thing, inches squared. And this is all surface area of a sphere. Now, here we go. We got finding surface area. Earth's equator is 24,902 miles long. What's the approximate area of Earth, or surface area of Earth, round to the nearest 1,000 square miles? Well, if I've got the Earth's equator's distance, I know that was found by circumference. Okay, so circumference is equal to 2 pi r. So I can use that 24,902 equal to 2 pi r to find my radius of Earth. I'm going to divide both by 2 pi. Now here's the thing. When you do this in the calculator, put a parenthesis around 2 pi. I'm going to show you what's up with that. So if I was going to just divide 2 pi, okay, I'm going to divide 2 pi by 2 pi. You'd think that's 1. But that comes out to be that. And people are like, what's the deal? What I just did is I took pi and divided it by 2 and multiplied that by 2 and then multiplied by pi again. Okay? So I've got to keep in mind that if I want to take 2 pi divided by 2 pi, I should do it that way, because if I go 2 times pi and divide by 2 pi, I get that value. Okay, and that totally works. But if I take and do anything else, I get some funky numbers because I have to make sure parentheses are around that value on the bottom. Okay, so now with that thought in mind, I am going to take 24,902 and divide that by left parenthesis 2 second pi and get my 3,963. So 3,963.276,393. 276,393 is the radius in miles of Earth. Now, I'm not going to round that. I know that value's in my calculator. I'm going to use it in my formula. So I know the equation for surface area of a sphere is 4 pi r squared. So I'm going to quickly square that in my calculator. I'm going to put this in 3963.27 in my calculator and then evaluate. Okay, and they want it to the nearest 1,000 square miles. So I'm going to take that value and square it, that ant squared, times 4 pi. And that's going to give me that for my area. I'm going to pull this over so I can see it. So my surface area, SA, is 197387017.5 in my calculator. But remember, that's 197,387,017.5 square miles. I will just get it down to 197,387,000 because they asked me to do to the nearest 1,000 square miles. So that's my surface area of Earth, right there. And we're going to try to get this fixed. We're going to unlock that and pull that down so you can see that answer better. Okay, so now that is, somebody's got to do something with his units, so I've got to go back and take care of that. So we're going to talk about units here. So we're going to pull that over and say miles squared. And we're going to bring this back up. See if I can, I can stretch that out. Good. And we got that fixed. Shoo, for a minute there, I thought I was going to have to rewrite it. Okay, so I've got my units all dressed up there with miles squared. Now, it's your turn. What's the surface area of a melon with circumference 18 inches? Now, I just did something with really huge numbers with Earth. You're doing exactly the same steps with the 18-inch circumference. You're going to find the surface area after you find R. It's your turn. Turn me off. Give it a try. Go. Okay, let's get this one done. So again, I have circumference, which is 2 pi r. I've got to use this to solve for r. So I've got 18 is equal to 2 pi r. I divide both sides by 2 pi. Remember, the big thing that I have to be careful of is when I do this, I've got to divide with parentheses on both sides. So I go over to my calculator. I go, hey, I'm going to take 18. So I got 18 divided by 2 second pi, right parentheses, hit enter. I get 2.8647. Now remember, this 2.8647 is all in my calculator. That is equal to R. Okay, now surface area of my melon here. We're assuming it's a perfect sphere, all right? So 4 pi r squared, and this is ants. So 4 pi times 2.864, this stuff in my calculator squared. Okay, so now I've got 4 times second pi times ants, second ants squared, because that's got to be squared, enter. It's 103.132. Okay, and they say your answer to the nearest 10 square inches. So I get my answer here as 103.132, but they say, hey, to the nearest 10, so it's approximately, my surface area is 100 inches squared. Okay,